Good day, this is Professor Timothy Kentop. We're walking through data organization, modeling, and OLE automation in Excel. The assignment document explains that we want to create a series of calculations to model the changes in kinetic energy as mass is varied first, and then if we hold, and that's assuming that velocity is constant. And then we want to create another worksheet based on the first one, make some quick changes, copy it, and take advantage of the power of our computing platform, and then change the second worksheet so that we hold mass constant and vary velocity. And then we want to upload these into a Word document and then make changes and compare how kinetic energy varies when mass is constant or if velocity is constant and the other is changing. You're provided with two templates. One is a Excel spreadsheet with some basic headers and the placement. What we've done is combine some cells here. Remember that the cells of a spreadsheet are basically functional objects in a programming environment. They can receive input, they can calculate and process data, and they can generate output. They can show results, and so in that sense, everything that you would do in scientific computing and the process can be easily handled here. Whenever you have simple variables involving lots of numbers, iterative or repeating series, spreadsheets are ideal. The cells are referenced by the letter of the column and the row, the number of the row. Here is where you see which cell you're in. So I'm currently in A1, and if I move here, I'm in D5. And so one of the things I want to do before I start, I want to make two changes. I want to zoom in and make sure that that I can see easier, just to make life easier. And then I want to save as with this with your first initial and last name, and then let's see, the assignment number. So it's going to be 2.3 assignment. We're also going to do the same for the Word document. There's a Word template that was created to receive the interactive charts that are generated by Excel for the OLE automation, object linking and embedding automation. And the first thing we want to do in this case is to save as, same way, same exact thing. One will have a .xls extension, the other one will have a .doc extension, or xlsx and docx. So tkentop, 2.3 assignment, and there we go. The first 5 steps of the assignment document are actually created for you here with the initial structure of the template. So as we continue on the second page, we're going to build this first series. What we're doing here, let's explain what we've done. In organizing data for a modeling or for scientific computing, if there are any constants, we want to keep those in the upper left corner to the left side or up, because those will be referred to constantly. And in order to get a clean result with our chart, we want to arrange the calculation series so that we can cleanly highlight just those variables, dependent and independent variables, right? So we have a coefficient from our calculation of kinetic energy. We have a coefficient of 1/2 that never changes, and that's in the upper left corner. You can see in the upper left, that's our coefficient. And then we have the mass in kilograms and velocity in meters per second, and so that's what we've done here. Our kinetic energy calculation is going to be the coefficient times the mass times the velocity constant. So we're varying mass down the column, and we're holding velocity constant. And we're going to repeat this equation right here. So I'm going to use a little bit of magic and automation here. I'm going to create a formula that increases. You see here a rate of increase, 1.25. A factor of 1.25 would increase the mass by 25%. So if I say equals this quantity times, I'll use the asterisk, this cell's value, if I check with a calculator, basically it increases 25%, 1.25. Now, I have also changed the expression of decimals so that it only shows one decimal place, and that's important. So if the result you get shows more, you could go with 2 decimal places, and there's nothing wrong with 2, but keep it to 1 or 2 decimal places. I'm going to use this formula to fill down. But before I do that, I want to anchor this cell B9 as an absolute reference, so that as I copy it down the column, the spreadsheet's going to want to reference the next one, the next one, the next one, the next one down the column, and 1.25 is not listed down the column in the same manner. You'll see in a second. So I'm going to anchor B9 by putting a $sign in front of the column, and then a $sign in front of the row. And this essentially turns the B9 reference into a fixed anchor that doesn't change as I fill every equation that succeeds down the page is going to refer to this specific cell. And I also we'll see how that works again with the coefficient when we calculate the kinetic energy. So I'm going to hit enter, and I want to make sure that I still have the same result, and you see that the result hasn't changed even though I've added the absolute references $sign B, $9. Now I'm going to grab this cell and fill down. So I want to take it down. Let's take it down to 18. Yeah, let's take it down to 18. And I'm going to use some commands to copy this formula down here so that each cell further down is going to be a 25% increase, 25% of the mass value above it. So I'm going to press the Alt key and tap E while I hold down the Alt key. Edit. I'm going to insert I. So now I'm going to press I, and then I'm going to press D. And that fills down. So Alt E combination, then I'm going to tap I and D. And you see here that with each successive row down, the value of mass is increasing 25% over the previous value above it. So we're increasing 25% for each iteration of the calculation. What we have now now what we're going to do is take the kinetic energy and then do likewise with the kinetic energy. So if I want to calculate kinetic energy for the first value, where mass is 5 kilograms and the velocity constant is 20, I'm going to enter an equal sign. I'm going to say equals the coefficient, B5, times the mass, which is D5, times the velocity, times the velocity again, because velocity is squared. And I'm going to hit enter. And that gives me an initial value. If you grab your calculator and check for answers, you'll find that that's a correct result. But if I fill this down right now, I'm not going to get a good result because I need to anchor some of these cell references. I need to anchor the coefficient, and I need to anchor the constant velocity. The mass will change down the column. So what do I mean by change down the column? If you look here, the same thing occurred in the mass column. So you'll notice this says D5 and then D6. Even though I'm in D7, it's referring to D6 above. Now I'm in D8, but it's referring to D7. Now I'm in D9, but it's referring to D8. That's what I mean by changing down the column. So let's go ahead and anchor our coefficient, B5. I'm going to put a $B, $5. And then I'm going to leave the D column unchanged because that's going to change down the column. But I'm going to anchor the B13 reference, $B, $13, and $B, $13. I'm going to hit enter to see if my value changes, and it does not. I'll go ahead and change my number of decimal points to 2 decimal places just to be consistent. And I'll go ahead and highlight down, issue the same commands. I'll hold down the Alt key while I tap E. Then I'll press the I key and the D key. And you'll see here I have kinetic energy in joules. And so you see I have an increase. Now I'd like to create a chart, a line graph of both values so we can see how mass is increasing and how kinetic energy increases with increasing mass. So I'm going to highlight these two, and I will, from the insert menu, I'm going to go to the recommended charts option and select the recommended charts option. And what I want is a line graph, so I'll scroll down. I don't want a scatter chart, but a line chart would be ideal. I'm going to go ahead and select this one and click OK. Now it's common, depending on your view, when this pops into view, you can see that it might cover up the cells, depending on whether you're zoomed in or not. It's important, but you need to grab the outer handle, the outer outline of this, instead of clicking inside the chart to move it. If you click anywhere else, you'll be moving the chart title. What we want to do is show the result here. We also want to double click the chart title and then change the chart title so that it matches, we'll say KE as mass increases. We could add velocity constant. All right, let's see if that's not too long. Oh, it's just right. Okay. So at this point, what we're going to do is click Save, because we want to save. And it's always a good idea to save as version 1, save as version 2, save as version 3. This is called progress by revision. If you make a mistake, you can back up to a previous stage of your work. I'm going to do something really cool, though. I'm going to go ahead and I'm going to rename this, and I'll call this KE mass changes. And now I'm going to right-click it, and I'm going to copy this. And I'm going to copy it. I'm going to move it to the end and create a copy and say OK. Well, now it looks like I have actually I do, I have a complete copy of the same spreadsheet, except this one is going to be KE velocity changes. So I'll change the name of this, rename, KE velocity changes. I'll get rid of the 2 at the end because it's not the second instance of that same spreadsheet. And now I'm going to make some changes. Kinetic energy as velocity changes. And over here on my title, as velocity increases, mass remains constant. Okay. And I'm going to change the header of this. Now mass was 5 kilograms. I'm going to make that here, and I'm going to say mass constant 5 and velocity 20. That's what I'm going to do. So mass constant 5, velocity constant 20. And you see instantly we get a different result. Would be ideal if I could put both of these side by side. And that's the cool part. So now I have two charts showing the variation, and I can visually change, but it's hard to see a difference there. I mean, I know that as I increase mass, the kinetic energy increases, and it seems to be the same kind of thing. Wouldn't it be nice if I could... Oh, there's one more thing I need to do here with the velocity. So in here, I need to change the formula. So this doesn't look right. I mean, that's one thing that's good about having a visual representation, is that if there's something that's off, guesstimates or estimated outcomes are a really important process of scientific computing. So what's happened is that I'm suspecting that these are still one and the same result because of the formula. And here's what I mean by that. In this spreadsheet, we kept the mass constant, but we squared the velocity. Now what we need to do is change the absolute reference, or $ anchors, to point to the mass here on this one. And that's what we don't have. That's why the result is not looking like it should. So I'm going to leave the coefficient reference $b, $5 the same, because that part of the formula is still the same. And I'm going to leave the velocity reference for d5 the same, because that's going to increase down the column from 20 to 25 all the way down the column. And the issue here, though, is that mass is only used once and velocity is used twice, and you see I have these inverted. So the mass is what needs to be anchored. So this needs to become, actually, yeah, so what I meant to say earlier was I need to change the reference here. $D, $13. No. $B, $13. And then this needs to be D5 times D5 without the $ references. So D5, I'm just going to type this in, times D5. Oh, yeah, look at the jump in what happens when we increase velocity and it's squared. Oh, I get a huge jump right here. So that's starting to look like, yeah. Now all I have to do is copy it down the column. So I just want to verify to make sure I have this absolute reference for the coefficient, this absolute reference for the mass in B13, $B, $13, and then I have this value times itself, only that's going to change. We want this value to multiply by itself, this value to multiply by itself. So we're going to copy this formula now down the column so that it replaces all of these previous formulas. And do the same thing. Alt-EID. Oh yeah, that now it's a radically different result. And look at the difference in scale. Now it's obvious when we flip back and forth, the scale here goes to 20,000 joules, but over on this side it runs into 330,000 joules. So that's a huge difference. One last thing, we'd like to automate how we can update changes in our calculations. That's a useful habit of designing and structuring our data so that we can easily make changes and then run new series and then update. And in documents, this is especially problematic because it's easy when the chart changes here, but what we'd like to do is also to automatically update the chart here. So what we're going to do is use the chart here, and we're going to click on the edge of the chart so the entire chart is selected, not just the title of the chart. And we're going to copy, not the image, but copy. And then we're going to go into our Word document, and we're going to select paste, and we're going to select the second option from the right, which is keep source formatting and link the data. We don't want to embed the data, we want to link the data. I'm going to go ahead and click this option, and now I'm going to click this chart and size it down a little so that it fits nicely next to the next chart we're going to insert here. And I'm going to put a space or two right here. And yes, I'll put a space here. And then I'm going to do the same again with my velocity changes. Select here. Whoops, not file. Home, copy, not the picture, but the chart. And then paste with linking. There we have it. It's very easy to resize this by dragging the corner out so that we maintain the aspect ratio. But now, side by side, we can see what happens. Here's where the coolness factor comes in. If both of these files are open and I change. So let's say that the scale runs to 20,000 here and 350,000. What happens if I change to a 50% increase? Let's increase the factor of iteration by 50% each time for both the changing mass and the changing velocity. I'm going to change this from 1.25 to 1.5. Boom. And I'm going to go over and do the same here so that I have an apples to apples comparison of what happens when I do this. Boom. And now I'm into 40 million joules, right? I'm approaching 40 million joules. And what happened on our Word document? It's magic. I did not have to copy and paste over again. Think of all the different reports you could do in a lab environment where you have to iteratively change. How many cycles of data and trials that you do. You want to save both files and you want to submit them for your assignment. And this concludes our session on Excel data management, modeling, and OLE automation. Thank you for joining us.